All right, here is number 1 on your review. So remember, this should be in your own words, but I'll go over some that I kind of think it would be. So for included side, I would say this is a side between two given angles. So in your definition, something about the word between, because that's the big kind of meaning of included. So side between two given angles. And then included angle would be the angle between two given sides when we're talking kind of triangle congruence. So if we took a look at this, like if I drew a triangle here for this one, so between, so included side would be if I gave you kind of two angles here. So if we talked about this angle and then this angle, the included side would be the one right between those two. And if we were talking included angle, again, we would have two sides that were given to us, okay, and the included angle would be between them. So if we had like this side marked and this side marked, then the included angle would be the one right between those two sides, so right here. So you can kind of think about it as these two sides are the ones given and they make that angle. So you can see that angle is between them. Coincide kind of lands on, okay, lands on top of or something like that. So if two vertices coincide, they're right on top of each other. Parallelogram, okay, in your words again. So maybe you say a four-sided figure, maybe you say a quadrilateral, but a quadrilateral with two pairs of opposite sides parallel. Congruence statement is a statement that pairs corresponding parts of two figures. So the order matters. It's things like ABC. So a congruent statement is the thing that's like ABC is congruent to DEF. Okay, and then the corresponding parts are matched up in that. So A would be equal to D, B would be equal to E, C would be equal to F for the angles, and then side AB to side DE, and so on. Isosceles, okay, so a triangle with two congruent sides, and really it's at least two congruent sides. Okay, so that would be isosceles. All right, then in number 2, we've got some different figures and we're given some information here. So we've got in this first one, should be a parallelogram. It doesn't explicitly state that, but this should be a parallelogram. And if we know that angle C is 76, how are we going to find angle B and angle D? So a couple of different ways here. So you could, opposite angles are congruent. So you would know angle A is 76. Then you could take the total. So you know B and D have to be congruent. So you could take the total of 360 degrees in a quadrilateral and subtract both 76s to get 208, and then 208 has to be split evenly between those two angles, so divide by 2, and you'd get 104 for each of angle B and D. So that's one way to do it. Another way is to think of the parallel lines. Okay, so remember that these two lines are parallel, and then you could use this as a transversal. So the angles right next to each other, this one and this one, have to total 180. So you could also do 180 minus 76 to get that 104. And then again, no opposite angles are equal to each other. So a couple different ways to do that. This next one we see an isosceles triangle. So we would know that the base angles are identical. So this one would be equal to 35. So angle K is also 35 degrees. Then to get angle J, we know the total of a triangle is 180 degrees of all three angles of a triangle. So then we could subtract off both of those 35s to get 110 degrees for angle J. And how did we know that these two were congruent for our explanation? Because base angles are equal in an isosceles triangle. And for this one, if you're doing your explanation, that opposite angles are equal. Okay, or here, if you were doing this one, that consecutive or adjacent angles or angles next to each other equal 180 together. All right, and then in C, we see a kite, and you can see that you could do a reflection over this line and they would land right on top of each other. So we've got angle X here at 94 degrees, and then angle ZWX, so this big angle here at 112. So if we think about flipping this triangle over this green line, we would see that angle Z is going to be the same as angle X. So we would get 94 degrees because those are images of each other with a reflection. So angle Z is the image of angle X with a reflection. Okay, which won't work this way. Okay, well, they're not equal this way, so we're not going to be able to flip W down to Y. But we do know that the total, so a couple ways here you could do this. Okay, the total is 360 of the entire kite. So you could subtract 94, and subtract 112. And if you do that, then you would get 60 degrees left over for angle Y, so ZYX, this big angle. So that's one way you can think of it. Another way would be kind of that there are two triangles here, so you could think about that you know this one right here was 94. And then this one right here is only half of that 112. So if you split that 112 in half, since you can reflect over here, this one would be 56. In which case, to get this angle, you could do 180 minus each of those and get 30. So then you know that each side of this angle is 30 to get that total of 60. All right, then taking a look at this one, if we're going to be talking about explaining in two different ways using rigid motions or triangle congruence. Remember, when we do rigid motions, you want to make sure that you're talking about what rigid motion you're doing specifically and how each of the parts land on each other. Okay, so I know WX is equal to WZ and XY is equal to ZY because it's given on the picture. Then if I do a reflection of WXY over YW, okay, I know W prime will coincide with W because it doesn't change, and Y prime will coincide with Y because it doesn't change, okay. I also know X prime will coincide with Z, and you have to explain this since that one actually flips over. And you would say because X is the same distance from W as Z, and X is the same distance from Y as Z. Okay, so just saying that you know X is the same distance from W as Z is and from Y as Z is. So then they will land on top of each other. And so therefore, XWY and XWY and ZWY are images of each other, so they are congruent. Okay, so that could be kind of your rigid motion. So again, you explain how you know everything lands on top of each other. Okay, making sure you say what specific rigid motion you're doing. Okay, so reflecting what figure over what line or whatever rigid motion that happens to be if you're rotating or translating, and then how you know each piece coincides, okay, to match up each vertice. Then if you're doing triangle congruence, okay, kind of a similar start. You start with saying what stuff you know is congruent. So we knew these pieces were congruent because it was given on the picture. Then the last piece that you know is that WY is equal to WY because it's the same segment. Okay, so you know this kind of middle piece here because it's the same segment. So then you see all three sets of sides. So then you know triangle WXY is congruent to triangle, and I said WXY this time, so WZY by side, side, side. Okay, so that's, you got all the pieces, all the information in there to use side, side, side. So you saw all three sets of sides were equal. You put them in your proof with a justification. And then you said which triangles were congruent and why. So then you were able to say this and use side, side, side. Again, this side, side, side you had in your proof. So now that we've proven that the triangles are congruent, how do we know X is congruent to Z? Okay, so either if you like this one, so we would say angle, okay, so you have a couple options for this. So angle X is equal to angle Z because they are images of each other. Okay, so that would be from the transformation idea that they're images of each other. And also because they are corresponding parts of congruent triangles, would be kind of from using the congruent triangle way. So let me change the color here. So because they are images of each other would be from your rigid motions, okay? And because they are corresponding parts of congruent triangles would be from proving the triangles were congruent. Okay, so a couple justifications there. Then in number 4, you just need to mark up pictures to match what's given here. So side, side, side just means all three sets of sides congruent. So marking up the corresponding sides with tick marks. So something like that. Side angle side, you could just pick an angle first, and then you need the two sides on either side of that to be marked as congruent. So you have the included angle, so be sure you don't do something like this where you pick an angle and then sides where the angle is not between it. So this would be bad because here's your two sides and this is not the angle that you chose. Okay, so this would be a side, side angle. This wouldn't be an example of side, angle, side. Angle, side, angle. So I don't know, pick a side first. So if I want this side to be the one side that I'm using, then your angles, okay, on either side of it. So this one with kind of the short side, I'm putting with one tick in it. And then this one on the other side with two ticks. So again, be careful here that you're not picking two angles and then the side not between it. So if you pick this side, that is not the side between the two angles because here's the angle, here's the angle. So the side needs to be between it. Okay, so it's wanted the side between those two angles. This one right here would be two angles and the side not between, which is not what this asked for. All right, and then how do we know each of these? So given this parallelogram, how do we know each of these statements? So how do we know EF is congruent to GH? And this is because they're opposite sides. and opposite sides are congruent in a parallelogram. How do we know angle FHG, so this angle here, is congruent to HFE, this angle here? Okay, so we can see that they make this kind of Z here, so they are alternate interior angles that are congruent. So when we have parallel lines, which we know HG and EF are parallel, because it's a parallelogram, then alternate interior angles are congruent. And how do we know HE is parallel to GF? Because opposite sides of a parallelogram are parallel. How do we know angle HEK? So HEK, this one here, is congruent to KGF. So this one here, again, we've got another set of alternate interior angles. And I'll actually write it all the way out this time. So alternate interior angles are congruent. All right, then number 6, write a sequence of rigid motions that takes the figure ABC to KLM in each of these. So in this first one, we've got fill in the blanks. You just have to kind of follow along with matching parts. So first, we would translate point A to what point? So which point matches A, and that's K. So translate point A to K by directed segment AK. Then rotate around the point that you just got together. So once you've translated, once you have one set point, that's what you're going to rotate around until B, and remember this was B, coincides with its matching part, L. Okay, so then we would rotate this until B matches L, keeping K the same. And then how do we know that C will actually land on M? Okay, so we know point C will land on M because they're the same angle, okay, because we've got this angle the same, and they're the same length, or the same distance from point L. So then write your own rigid motions, okay, so you can use this to kind of help you. So you can translate point A, okay, so we're going to translate point A to K by directed segment AK. And then once you've gotten, so now we have point A and K matched up. So now we're going to rotate around point K since that one's matching, okay, until B coincides with point L. And you can put point B in front of here if you want. So now we've got A on K and we've got B on L. Then we know C will land on M. And how do we know C will land on M? Because it's the same angle away. Okay, so it's at the same angle and it's the same distance from L. Okay, because B prime is now on L. So C is the same distance from that as M is. All right, then looking at these different translations here to move these figures, okay, and we want to move D to B, E to A, and F to C. So you want to make sure that you're looking at the congruence statement, not necessarily the picture, because we might get screwed up which sides go with which here. So this one says translate DEF using directed segment EA, which is fine because we want E to land on A. We talked about that right here. So we want E to land on A, so this is good. Then rotate DEF until around point A, which is the one that we have set already, right? So we got E on top of A, until D prime coincides with C. So D prime, we want to coincide with B, not C. So we do not want D prime to coincide with C. And look at each of these, okay? It starts the same. So it has all of these translate by segment EA. So all of this is good. Okay, then every single one starts to rotate around A until D lands somewhere. Okay, and we want D to land on B, so we do not want it to land on C, so that rules out A and B. Okay, so then this one has it landing on B, which is good, and so does D. Okay, so what we've gotten here is we've gotten A onto E, and then we've rotated until B, until D coincides with, oops, I moved the wrong one, hang on. Okay, so we took this and we moved, okay, until E landed on A, and then we rotated until D landed on B. So now we've got points A, B connected, so we want to reflect over that line. So we're going to want to reflect over AB. So that's this one.